Hi everyone, and welcome to the exponent rules video. If you feel like you already know your properties of exponents or your exponent rules, you don't need to watch this, you can continue on to the next video. If you're like, I know there's rules, I don't necessarily remember them, or I don't know why they're the way that they are, this is the video for you. This is just kind of going over why we have so many exponent rules. I don't know if I'll be able to go over all of them, but I'm definitely going to explain why some of them exist. So let's take a look. Our exponent rules or properties, however you want to say that. So the first example we have is we have a to the m times a to the n is equal to a to the m plus n. So the reason this is a rule, we'll call this the product rule. Should label that first. The reason this is a rule is if we were to use an example of say of like 2, so like 2 to the power of 3 times 2 to the power of 5. Well, what does that really mean? Well, 2 to the power of 3 is just 2 times 2 times 2, and 2 to the power of 5 is just 2 times 2 times 2 times, well, I shouldn't have chosen 5, but it's 2 times itself 5 times. So what I really have here is 2 being multiplied to itself a total of 8 times, or 2 to the power of 8, which is the same as 2 to the power of 3 plus 5, just adding my exponents together. So that's kind of why the product rule exists. These rules are really more just like shortcuts that we label as rules. So the next one we're going to talk about is the quotient rule. And the quotient rule states that a to the power of m divided by a to the power of n is equal to a to the power of m minus n. So we're going to be using an example that we just used. So we're going to do 2 to the power of 5 over 2 to the power of 3. Now again, if we were to write this out completely, we're going to get 2 times itself 5 times on the top, and 2 times itself 3 times on the bottom. Now remember, anything divided by itself is 1. So 2 divided by 2 gives us 1, gives us 1, gives us 1, and we are just left with 2 times 2, also known as 2 squared, which is the same as if we took 2 and we did our top exponent and then subtract our bottom exponent. So that's kind of where we get our quotient rule from. Let's see, other rules that we have. We have the power rule. I think I'm only going to be going over 5 rules today. There's more than 5 rules, but these are kind of the 5 big rules, and they're all based off of each other. So for this rule here, we're going to have a to the m to the power of n. That's going to be the same as a to the myself. So this is the same as a to the m times n. So I'm going to be using a slightly different example just because I don't want to have to write out 2 15 times. So what we are going to have here, let's come up with an example. If we have 4 squared to the power of 3, that'll be 4 squared to the power of 3. So remember, 4 squared, instead of just writing that as 16, we're going to write that as 4 times 4 to the power of 3. And remember, anything to the power of 3 is just times itself 3 times. So it's really 4 times 4 times 4 times 4 times 4 times 4. Or really, we're just multiplying 4 to itself 6 times, which is the same as 4 times, or 4 to the power of 2 times 3. So all of these rules are coming from if we just wrote things out the long way, but we don't have time for that, so we're just using all of these shortcuts. Oh, you know what? I'm actually going to be going over 3 more rules. Sorry, 6 rules total. The next one is going to be our actually, I think we're going to do our 0 exponent rule, then we'll do our negative exponent rule. So our 0 exponent rule states that, where is it? A to the 0 is equal to 1, or anything to the power of 0 is 1. And we want to talk about why that's true. So we're actually going to bring it back to a previous example we had. Instead of 2 to the 5th over 2 to the 3rd, we're just going to do 2 to the 3rd over 2 to the 3rd. Something that we stated earlier is that anything divided by itself is 1. So we know that 2 to the 3rd divided by 2 to the 3rd is 1. But we also know from our earlier quotient rule that we can just subtract our exponents, and it's going to simplify that for us real quick. So this is going to be 2 to the power of 3 minus 3, also known as 2 to the power of 0. So this is kind of giving us the reasoning that we could really use anything. So any base, or 2 to the power of 0, is going to be equal to that 1, kind of through proxy. So that was our 4th rule. We've got 2 more to go. The next one is going to be our negative exponent rule. Where's my black pen? There we go. And again, each of these has like a variation on them, so you may see more than one negative exponent rule. They all mean the same thing. So a negative exponent rule, if we have something like, where is it? A to the negative m is equal to 1 over a to the m. So why is this true? So let's take a look, and let's try an example. Let's try 1 over, let's do 1 over 2 to the 3. So it's like our previous problem, except instead of 2 to 3 in the numerator, we're just going to have a 1. Well, we know that at anything to the power of 0 is the same as 1. So I'm going to rewrite this as 2 to the power of 0 over 2 to the 3rd. And we also know from our quotient rules that we can just subtract our exponents and get just a single base. So this is the same as 2 to the 0 minus 3, or 2 to the negative 3. So we can see here that 1 over 2 to the 3rd is the same as 2 to the negative 3. So we're just switching that around. Our very last rule, I'm going to call this our fraction rule. I think it's our rational exponent rule, I think is the official name. So here's our rational rule when it comes to exponents. We're going to have a to the m over n is equal to the nth root of a to the m. Now this seems like a lot, but I promise it's not as bad as you think. So when I think about this type of problem, I think about my exponents and my rational functions. Let's call it, let's see. Oh, sorry, not, let's see, let's use x squared. And I might ask you, what do you have to do in order to undo this? Well, we're going to have to use the square root and square root. We know that those cancel out, and we just get x, or x to the power of 1. But why is that true? Well, let's look at this in terms of exponents. So if I want to put this to the power of something else, we're going to be using our power rule from up here. I need to put this to another power to multiply together to be equal to 1. So what do I have to multiply to 2 to be equal to 1? Well, that's going to be 1/2. 2 times 1/2, that's going to give me x to the 1. So I can see here that square root is the same as to the power of 1/2. Let's try this again with a different place. So let's try this with x cubed. Well, in order to get rid of an x cubed, you're going to use a cube root. It's going to get you x to the power of 1. Same type of thing. If we have x cubed, what do I need to multiply to 3 to get 1? Well, I'm going to multiply that to 1/3. It's going to get me x to the power of 1. So this means if I have something, let's say x cubed to the power of 1/2, this is the same as x to the 3/2 if you multiply those together. But we can also say that this is the same as the square root of x cubed. Square root kind of has this invisible 2 right here. If I didn't write that 2, that's also okay. It just means square root, but we're just really going back and forth. I don't know if my explanation of this rule was super clear, but it's just showing kind of how we've been using this rule without even realizing it. So these are the explanation of our rules. If you want me to go over any other rules you find, I can do that. Well, let's head on to the next video.